Okay, hello everyone. I'm Iulian Baciu. In this session, I'll present you a tool that will help us visualize the impact area of our code changes. The objective is to create a schematic where the effect of our changes spread into the application. For any questions you will have during the presentation, just to make sure you won't forget it, please go to slido.com and at the event, hashtag #AskJulio, just go from there. Okay, now to introduce myself. I'm a software developer at Wayfare with 2 years of experience. Until now, I have worked on 2 commercial projects. One of them is a financial application on which I'm still active, and the other one, a tool that I've presented last year at the conference in Dublin. To get back to the actual subject, our agenda for this session is for me to present you the idea which stays behind the tool development, the need that we encountered and driven us to develop it, the technologies that we involved. After that, I will present you the components of the tool, the configuration, the processes, and how everything works. After that, as a proof of concept, we will see the tool in action, as I prepared a little demo, not too complicated. And because this tool is not a finished product, and many improvements can be added to it, our team have discovered some items that we can add. At the end of this presentation, I hope to be able to answer all the questions from slido.com. Can you imagine the impact? Well, okay, can you imagine the impact of a forgery code? The idea behind the topic came as a result of for the lack of support for visual representation of the relationships and the interactions between the 4GL code files. This is needed in certain situations like technical or functional analysis against a progress application. In order to achieve this, our team came up with an integration between a custom-built solution and a third-party tool called Neagoe. This became handy for developers, testers, and functional experts on a daily basis, as it provides more extensive insight against the impact of change in a file in the whole application. The need. How many of you found yourselves in a critical situation where not all test cases were covered, and this to lead from malfunctions, or was not enough transparency to which functional cases of the application will be affected by the changes? We currently are working on a progress of an edge modernization project of a vast financial application. This required quite strict control of the changes produced to the logic, so it determined us to build a visual way to foresee the impact, both technical and functional, of touching a single piece of code in the entire application. This was done in order to reduce the risk of releasing inconsistent functionality. For this tool to take shape, we needed a development environment for which we used the progress of an edge, some data interchange formats like JSON and XML, and somehow figure out a way to transform our collected data into a visual schema, and for this we've chosen Neagoe. JSON and XML are the well-known data interchange formats that we also used for configuration files and to make possible the communication between processes and to define the Neagoe diagram. Neagoe is a web or standalone third-party open source application which is used to design different types of diagrams like flowcharts, software applications, business or engineering diagrams. Why Neagoe? Because it was the first of which we found that has a human readable content residing behind the visual diagram in form of an XML. And because it's free. Progress Developer Studio being our development environment for the current project, and the tool itself being coded under the same technology, it became easy to integrate it within the commercial project setup. But for this to take place, we needed to add some adjustments to it. First of all, for the ease of usage, we went to customization editor to add entries into manual toolbar entries and into editor context menu in order to have the tool at disposal. Secondly, the tools project needs to be added into the same workspace as the target project. And the last trick is the fact that new propat entries need to be added to the target project. These entries need to point to the source and config files of the tool. The tool consists of several components. Configuration files for it and cosmetics used for drawable, a process that collects relevant data about files and the relationship between them within the target project from Xref compiled files. And the second process being triggered on request that determines the hierarchical set of dependencies starting from target source file and prepares the drawable diagram. This is the general overview of how the tool works. We'll get into details about the components and how everything looks like and behaves. To run it, we need to provide some information about the target project and some drawable, some for drawable. And let's see how the configuration files look. We have a configuration file which contains database connection strings alongside database connection names, as you may have several databases. This is needed in order to make possible the compilation of project source files, regardless of which source was focused in Developer Studio at the moment. A second configuration file contains data about target project setup and general information to organize the tool's work. Root path is the location of the workspace in which target projects are nested. The output path is the location in which files generated by the tool will be dropped. In templates path, store the path to the XML templates that are used to generate the drawable diagram. Drawio.exe path is the location of the drawio entry point. This is needed because the tool opens its result files directly into drawio. Propat contains a list of all propat entries from all projects that are needed for the compilation of files to be possible. As you may have applications with multiple layers. Technical impact path sets the scope of the compilation, as you may want to compile and analyze just a set of files or just a layer of the application. And the last one, source file extensions, is a list of files which will be taken into consideration. This is needed because directories and files will be parsed using progress OS commands. The last configuration file contains customization and data needed for the drawable diagrams. In here are specified the default dimensions for the elements, distances between links, and different colors, each with its own purpose. Now that we have the tool fully configured for the target project, it is time to detail the processes behind the tool. In order to be able to generate a diagram file, first the relevant data needs to be collected, and this will be handled by the process being displayed next. At the first, when the process of collecting data is started, it loads the tool the main configuration files. Based on the root path and technical impact path that were read, the tool starts to recursively read source files from project directories using OS commands. If the extension of the file is present in the extensions list, the file is collected and a unique ID is assigned to it. Before moving to the next step, the list of collected files is generated as a JSON format file. Based on the generated list of files, the next step from the collect data process will be able to dynamically connect to the databases and dynamically set the ProPath as configured in order for the compilation of all files collected to succeed. In the next phase, it iterates to the entire list of files, each being xref or cross-reference compiled, and its content being parsed for keywords indicating a relation. Keywords like include, inherits, implements, run, new, invoke, these all represent relevant information and will be taken into account. These relevant references between files are collected. We'll be calling them filings, and the files will be called file nodes. In the end, having a complete list of relationships between all files of the target project. As a first step in the process, the links and nodes will be stored and exported as a JSON file. This set of data represents the basis for the second process of the tool, the generate diagram process. The second process is the one that generates the diagram. It only works as long as the data being collected in the first process is available in the form of the JSON file we mentioned before. The generate diagram process starts by first creating the configuration needed for generating and exporting the diagram data. It also loads the previously generated JSON file containing the file nodes and filings, which will be used later on. Based on the selected source file in Developer Studio, the process will start calculating the path scope. Compared to the reference option in Developer Studio, which shows only the first level of dependency, calculate call paths goes deeper in a recursive manner to determine the call path tree of dependencies between files. In case of classes or interfaces being involved, it also determines the inheritance and the implementation paths for each of those. A call path consists of an enumeration of file nodes in the order they are referencing themselves. The refinement of call paths is done by removing the ones which are included as part of other longer call paths. The purpose is to remove overlapping call paths. Next step is to determine nodes, link, and link labels geometric position in Cartesian coordinates. This process starts with parsing all the call paths determined, starting with the longest ones. What that means, parsing a single call path means iterating through its enumeration of nodes, and first determining the coordinates for the nodes, putting them into the diagram, then determining the turning points of links and also the position of labels on links. The process tries to avoid overlapping of nodes and links so that the diagram is easier to read. Valid information is also placed on the diagram, like file names, packages names, packages paths, link files, link directions, and enhancements like different colors for the nodes and links are also used based on the draw diagram file. Okay. Generating the XML diagram script with all the values that were determined is done by using templates for nodes, links, and labels that were extracted from a sample draw diagram content. The match happens, and the only part left for the user is to analyze the draw diagram. Apart from the draw diagram script, it also generates a log file in which each call path is written separately. This has a debugging purpose only, in case you think that something is fishy in the diagram or it is hard to understand, you can trace it back in there. As I told you, I prepared a little demo to show you how it works. Okay, and then we have an image. Here we can see what we added in the editor context menu and the customization editor. So this one. Also, the two entries here. First one, we also added the tools project into the workspace. And also two entries in the product. Now, all you have to do is start the process for a file, a code file, for which you want to see the diagrams. First of all, we have to click on the flashing thread, as I mentioned it. This shows you a message on which it will tell you that it will read this folder, best cars at project source file folder, and it will analyze 99 source files. Here we have a process window which runs very quickly. The other step will be to calculate the impact. Okay. As you can see, it draws a diagram for which the source file is the render company class. This one implements interface 2 and interface 1 and inherits from a base class. It's also called and used in these other classes. I don't know if we go simple changing code. Also change the diagram. Now we see that the paths for the implementation of those two interfaces has disappeared because they are not used and not referenced by the class. Now to give you other examples. Have a procedure. This diagram is a little smaller, just so you can see referencing. And something else. as I told you in the beginning, we were also thinking of little things that the tool can be improved with, like making the drawing of the implementing and inheritance paths because in cases of larger hierarchy of superclasses or many interfaces, the diagram can be polluted with information that is not needed or not relevant at the time. Also, taking into consideration the interface inheriting other interfaces would be an option. Also, further improvement of the overlap avoiding of links algorithm, and I don't know, getting more detailed information about internal procedure and methods that are making the calls. And as it is, the tool has some technical limitation that we have encountered because dynamic calls to a procedure can be determined at compile time. Also, persistently run procedures with the handle being parsed into other programs. So also something that we can determine, and also not seeing which internal procedure or function is performing the call, or nor which one is called from the other colleague. Okay, now means we have plenty of time, and we're glad to try and answer some questions. Oh, try to do that.
Sorry, no more time.
Okay. Is there a specific dry IO version used in the tool? No. At first, I had something installed on my computer. In the meanwhile, it updated itself, so it's not a specific dry. Is there a limit in the number of files in the project? No, but the bigger the project is, the longer it will take to analyze and also draw the diagram. On how many projects are using the tool so far? Only one. We developed it just for our usage, and because the team is new on the project and we don't have so much functional knowledge. We wanted to see where in the entire application our changes will affect the functionality. So we developed it for us just to make our labs easier, but it can be well improved. It's a commercial tool? I think yes. Have you thought about performing some reverse engineering and build classes based upon the diagram? Yes, but it will be a hard work to do that. We just give it a thought, and we had a brainstorm some days ago. How did you validate the results, the diagram? Well, after we developed it, we started to use it on parts of the application that we knew and we had the knowledge about it, and it was fine, it was okay. It performed well. Did you think about a way to dynamically analyze the dependencies, validating and alert the developer of possible issues? I have to say no, but we'll give it a thought. Could we use this to identify dead code? Maybe yes, if you just eliminate the functionalities that are shown in the diagram, and I don't know, take the others that will not be shown there, Any other questions? Okay.
When it's commercial, is there a trial version to get an impression of the own application?
Okay, that's a good question. We can do something like that. I told you that it's not a finished product, and it was done by me and Filip just to make our lives easier. So something very quick that yeah, we thought that it would be interesting to show to the others.
So if you're referring to a demo to be run on your application, I think it's doable. Yeah. Maybe later you can join our booth or tomorrow and we can discuss about it.
Looks like you only considered an object-oriented ABL application, right? So I didn't see anything about include files and things like that. Is it considering that? Or?
Yeah.
It is?
Yeah.
Okay.
I think that in this example there are now includes of that, but it takes consideration. Yeah, understand.
You said that you tried to eliminate overlapping dependencies. Didn't you think that it would make more sense to leave them there to better understand the connections between different classes and the procedures? Because if you eliminate something that you don't see this connection.
But you eliminate just common paths. If a flow goes to the same path, you just draw it once. Okay, something else? Okay, with that, I want to thank you all for your attention, and I would like to invite you to the Wayfare booth to know each other well and get some more information if you're interested. That's it.
I was looking for a way to